Okay, now we're talking about qualitative analysis. These are tests to determine the presence of a certain substance in an unknown compound. So, for example, if I have a solid like the one in this conical flask, and I want to know if this solid contains carbonate or not, if it is something carbonate. If it is a carbonate, I add acid, and if I add acid to any carbonate, you should know that this will form carbon dioxide gas. So what I see or what I observe is effervescence. The word effervescence means fizzing, or it means bubbles of gas. So if effervescence is too hard to spell, you can just write bubbles of gas, but they mean the same thing. So effervescence or fizzing or bubbles of gas. And this gas is supposed to be carbon dioxide. So when I pass it through lime water, it turns the lime water milky. That's how we test for carbon dioxide gas. So if he says test for carbonate, we say add a specific acid. It doesn't have to be dilute HCl. It can be any acid, but add a specific acid. For example, dilute HCl. Now, if this is a carbonate, I will get effervescence or bubbles of gas that turn lime water milky. Now, if he asks me what is the name of the gas, the name of the gas is carbon dioxide. But that is not part of my observation. The word observation means what do I see? I see bubbles of gas that turn lime water milky. Why? Because carbon dioxide gas is given off. Now, this test can also be used to test for acids. Remember when we were talking about acids and bases, we said an acid is something that will turn litmus paper red, okay, or universal indicator paper red or orange or yellow. But what if he says test for an acid without using indicator? So he doesn't want you to tell me litmus or universal indicator paper. We want to test for dilute HCl, for dilute acid. I can tell him add something carbonate and be specific. Let's say add sodium carbonate. If the liquid is acid, then I will see bubbles of gas that turn lime water milky. Do we understand this? Okay, now the next test is to determine the presence of halides. Halides means halogen ions, so chloride, bromide, iodide. To test for any of these, it is the same test. Add dilute nitric acid, then aqueous silver nitrate. Remember, it could be silver nitrate or lead nitrate. It gives the same results. So we first add dilute nitric acid, then add aqueous silver nitrate. Now if I have chloride, I will get a white precipitate. We said a precipitate means a solid that forms from a reaction. If it's bromide, the precipitate is cream. If it is iodide, the precipitate is yellow. Okay, so these are tests that you need to memorize. And it's very important because it will be included in every single paper that you take. So you will have questions on this chapter in paper 2, in paper 4, in paper 6. You will always have, and paper 6 will be mostly questions about this. Okay, so remember that if I don't have any of these, so let us say I have a solution that doesn't have chloride, bromide, or iodide. What will happen if I add dilute nitric acid and aqueous silver nitrate? No reaction or no change. Okay? Okay. Test for nitrate. How do we test for it to see if something is something nitrate? I add aqueous sodium hydroxide, then aluminium foil, and warm gently. So remember, the test for nitrate is add sodium hydroxide, aluminium foil, warm gently. Now, if this was a nitrate, it will give bubbles of gas that turn damp red litmus paper to blue. And if he asks me what is the gas, then I'll say the gas is ammonia. Okay, so sodium hydroxide, aluminium foil, and I get bubbles of gas that turn damp red litmus paper to blue, then I have nitrates. Okay, sulfate, add dilute nitric acid, then barium nitrate, or hydrochloric acid and barium chloride. So it is barium something, either barium nitrate or barium chloride. I add it to something that has sulfate, it will give white precipitate. But if I add it to something that doesn't have sulfate, no reaction or no change. Do you understand Can you see what a precipitate means? It means the formation of a solid in the reaction. Okay, test for sulfate. Remember that 8 sulfate is SO4, 2 minus sulfite is SO3, 2 minus. Now, to test for sulfite, I add dilute hydrochloric acid and warm gently. This will give bubbles of a gas. When I pass it through potassium manganate, acidified potassium manganate, the potassium manganate will change from purple to colorless. So the original color of potassium manganate is purple. If I pass through sulfur dioxide gas, it will change to colorless. So the test for sulfite is add dilute hydrochloric acid, warm gently. I get bubbles of gas that turn acidified potassium manganate from purple to colorless. Now, which gas turns potassium manganate from purple to colorless? Sulfur dioxide gas. Okay, aluminium. Now, when we're starting here tests for metal ions. Now, for each of these, I will have two different tests. Either I add aqueous sodium hydroxide or I add aqueous ammonia, which is actually ammonium hydroxide solution. This is ammonia dissolved in water. And for each of them, I will get different results. So if I have an aluminium salt, remember that this is not test for aluminium metal, it's test for aluminium salt. So aluminium something, aluminium chloride, aluminium sulfate, whatever. Okay, I add sodium hydroxide. What happens if I add sodium hydroxide to something that has aluminium? White precipitate, soluble in excess, giving a colorless solution. What does that mean? It means that if I have in my test tube aluminium something solution, I add sodium hydroxide drop by drop. At the beginning, I will get a white precipitate. And then, if I add more and more of the sodium hydroxide, then the precipitate will dissolve and I will end up with a colorless solution. So, adding aqueous sodium hydroxide to aluminium ions, white precipitate, soluble in excess, giving a colorless solution. What if we add aqueous ammonia to something that has aluminium? Then I will end up with a white precipitate that remains. As I add more and more ammonia solution, the white precipitate remains. So we say it is white precipitate insoluble in excess. So the white precipitate does not disappear. Okay, please make sure you memorize all of these. Ammonium, test for ammonium. And remember that we're going to have a test for ammonia gas or ammonia solution. So now we're talking about ammonia solution, which is ammonium ions. What do I add? I add sodium hydroxide and warm gently. So on warming, I will get bubbles of gas. Remember that we just said in the previous chapter that if you add base to ammonium salt, it will give ammonia gas. So I'm adding sodium hydroxide, which is a base to an ammonium salt. I warm gently. I get bubbles of ammonia gas given off that turn damp red litmus paper to blue. Remember that ammonia is base. So to make sure that the gas given off is ammonia, I put a damp red litmus paper. It turns from red to blue. Remember that litmus paper, when it is used to test for acids and bases, there must be water somewhere. So if you put the litmus paper into a solution of acid or base, no problem, it works. But if I'm going to use it to test for a gas, then the paper itself has to be damp. It has to have some water on it in order to react. Okay, so test for ammonium, add aqueous sodium hydroxide, warm gently, results or observation, bubbles of gas that turn damp red litmus paper to blue. Name the gas given off, it's ammonia. Okay, now calcium, test for calcium. If I add aqueous sodium hydroxide to something that has calcium, I get white precipitate insoluble in excess. Insoluble in excess means I'm adding the sodium hydroxide drop by drop, I get this white precipitate. Now if I continue to add sodium hydroxide, so I have excess sodium hydroxide, the precipitate still remains, it doesn't disappear. So that means that the precipitate is insoluble in excess. Now, what if I add aqueous ammonia, ammonium hydroxide solution, to something that has calcium ions? Then I could get either no precipitate or very slight white precipitate. So you write all of that. So if we say aqueous ammonia with calcium, what is the observation? No precipitate or very slight white precipitate. All of it. Don't choose one of them. Okay? Okay, test for chromium. Chromium ions, if I add sodium hydroxide, at the beginning when you add drops of the sodium hydroxide, you will get a green precipitate. And then as you add more and more sodium hydroxide, the precipitate will dissolve and give you a green solution. So this is a green precipitate soluble in excess. What if I add aqueous ammonia to chromium ions? Then I get this gray-green precipitate, and it is insoluble in excess, means I add lots and lots of ammonia solution, I still get this gray-green precipitate. Copper ions are the only ones that give blue. So if he says it gives blue, then it's probably copper ions. Now, aqueous sodium hydroxide with copper ions will give a light blue precipitate. And as I add more and more sodium hydroxide, the precipitate remains. So it is insoluble in excess. If I add aqueous ammonia to the copper ions, I get light blue precipitate. But as I add more and more ammonia, the precipitate will dissolve. So that means that the precipitate is soluble in excess, and I end up with a dark blue solution. So if I add aqueous ammonia to copper, what is the observation? Light blue precipitate, soluble in excess, giving a dark blue solution. Okay? Iron 2. Now, with iron 2, you get the results, the same results whether you're adding sodium hydroxide or ammonia. If I have iron 2, whether you add sodium hydroxide or aqueous ammonia, I get green precipitate insoluble in excess, so the green precipitate remains. For iron 3, whether I'm adding sodium hydroxide or aqueous ammonia, I'll get the same result, red-brown precipitate insoluble in excess. With zinc ions, with both of them, any of them, we get white precipitate soluble in excess, giving a colorless solution. So that means you add either sodium hydroxide or aqueous ammonia in drops, you get a white precipitate. You add more and more of it, the precipitate dissolves, and it gives a colorless solution. Okay, let's try something. The results of 2 tests on an aqueous solution of X are shown. So he says he added aqueous sodium hydroxide and he got a green precipitate. Now, which one gives a green precipitate with sodium hydroxide? Is it copper 2 or iron 2? If you remember, it was iron 2 that gives green precipitate. What if I add acidified aqueous silver nitrate? Now, silver nitrate was a test for what? Chloride, bromide, iodide. But what if I get a yellow precipitate? I have which one? I have iodide. Iodide is the only one that gives a yellow precipitate, so that means that my solution of X was iron 2 iodide. Okay? Do you understand how to think about this? Okay, let's take a look at this. Which statement about aqueous sodium hydroxide is correct? When it is added to a solution containing sulfate ions, a white precipitate is formed. What was the test for sulfate? Well, we add what? We add barium something, right? We add acidified barium nitrate, nitric acid with barium nitrate, and that is when I get a white precipitate. But I don't add sodium hydroxide to sulfate and get a white precipitate. Okay? The next one says, when it is added to a solution of copper 2, a blue precipitate is formed, which dissolves in excess to give a deep blue solution. Well, we did say that copper 2 gives blue, but it dissolves to give deep blue solution with which one? With sodium hydroxide? No, with aqueous ammonia. So this is not the result with sodium hydroxide, this is the result with aqueous ammonia. Okay. When it is added to a solution of iron 2, a green precipitate is formed which does not dissolve in excess. Is that right? Yes, actually. If I add sodium hydroxide to iron 2, that's when I get a precipitate insoluble in excess. So actually C is the correct answer. Now, when it's added to ammonium, a gas is produced which turns blue litmus to red. Well, if I add sodium hydroxide to ammonium, I will get ammonia gas, but ammonia gas turns litmus from what to what? From red to blue. So that statement is not correct. Okay, A substance is heated with aluminium foil in aqueous sodium hydroxide. A gas is produced. Red litmus paper turns to blue. Now, I'm going to try and remind myself again, which test is this where I use sodium hydroxide and aluminium foil? That was test for what? Test for nitrate. Okay. Okay. 3 chemicals PQR are each dissolved in water. The table shows some of the reactions of these solutions. The pH of the 3 solutions was measured. What are the correct pH values of these solutions? So this is a question that we saw in the explanation. We said if I put P on sodium carbonate, that will give off a gas. Now, that means that P is what? What was the test for carbonate? Test for carbonate was I add acid and it gives off carbon dioxide gas. So P must be an acid. And we said acid means pH 2 or pH 7 or pH 13? pH 2. So my answer is either A or B. Then Q, if you add it to carbonate, no reaction. But if you add it to ammonium, you get a gas. And we said, what do we add to ammonium salts to get ammonia? That has to be a base. So base has pH 7 or 13? 13. So B must be my correct answer. And we said R does not react with carbonate, does not react with ammonium. That means it is neither an acid nor a base. So it must be something neutral with a pH 7. Okay, this is the other kind of questions that you will get in paper 6. So solid Q was zinc bromide. So he's giving me the identity of Q. The solution was divided into 3 equal portions, and he's saying complete the observations. Okay, let's take a look at the first question. He has what? Again, let's keep in mind, he has zinc bromide. So he's adding drops of aqueous sodium hydroxide were added to the first portion of the solution until a change was seen. Now, if I add drops of sodium hydroxide to something that contains zinc bromide, is this a test for zinc or is it a test for bromide? Sodium hydroxide is a test for the metal ion. So it's zinc, so I'm trying to test with zinc. Okay, what happens if I put sodium hydroxide on zinc ions? You should remember that if I'm adding it drop by drop, I get a white precipitate. And then if I add excess, what happens to the precipitate? The precipitate dissolves to form a colorless solution. Okay, the other question, drops of aqueous ammonia. Okay, what happens if I add aqueous ammonia to zinc? Remember that we said zinc, we get the same results, whether I'm adding sodium hydroxide or ammonia. So again, I add drops of ammonia, I get white precipitate. I add excess, the precipitate dissolves, and I end up with a colorless solution. Dilute nitric acid and silver nitrate were added. The first question I asked myself. Silver nitrate was test for what? Well, it was test for chloride, bromide, iodide. Which one do I have? I have bromide. So what am I supposed to end with? Cream precipitate. Okay, so this is another one. Solution M has iron 3 chloride. And he's asking, describe the appearance of the solution. First of all, how do I know the appearance? What's the color? First of all, iron 3 is a transition metal, so it must have a color. The compound has a color. How do I know the color? We said iron 3 with sodium hydroxide gave what? When I was testing for iron 3 with sodium hydroxide, it gave reddish-brown precipitate with sodium hydroxide. But if this is aqueous, then this is a reddish-brown or a brown solution. Solution M was divided into 3 equal portions in 3 test tubes. Dilute nitric acid and silver nitrate were added. Again, remind yourself, silver nitrate was test for what? It was test for chloride, bromide, iodide. Which one do I have? Chloride. What does it give with chloride? It gives white precipitate. Now, dilute nitric acid and barium nitrate. Again, I ask myself, barium nitrate was test for what? Keep the tests in front of you and try and memorize them as we go along. Barium nitrate is test for what? It's test for sulphate. If I have sulphate, I'm supposed to get a white precipitate. Do I have sulphate? No, he said it's iron 3 chloride. I don't have sulphate. So if I put barium nitrate, I don't get anything because I don't have any sulphate. Okay. Drops of aqueous sodium hydroxide were added to the third portion until a change was seen. Okay, if I add now sodium hydroxide to something that has iron 3, what do I get? What was the test for iron 3? I get a brown precipitate, or we called it a red-brown precipitate. An excess of aqueous sodium hydroxide was then added. If I keep on adding the sodium hydroxide, what happens to the brown precipitate? It remains. So the precipitate is insoluble in excess. So, see you in the next video.